Alright, so this is a coding walkthrough video for my first prototype, the open solar system exploration one. So what I'm going to do is walk you through this prototype and what you have to do and how the mechanics work and things like that, and then go through the code and show you how it works. So I'll just hit play and away we'll go. So the way it works is quite simple. If I press M to zoom out here, what you've got to do is fly your space rocket here all the way around to this moon here, which is orbiting around here. So this is mainly a prototype to test just mechanics and technical issues, essentially, to see if our game idea is possible. Evidently it is. So we've got this moon rotating around this planet here in orbit, and these two asteroid fields here. These are mainly to try and get my main theme across, this idea of pushing through the fear of the unknown that I came up with in my research. And we wanted to get that idea across here, so it's like you've got some fast moving asteroids that are quite scary, you've got to get through them. That is the only way to win as well. You can't win any other way. You can't just sit tight here because you won't win the game. You have to push forward and go into these asteroid fields even though you may die. And that, obviously, it's a bit ham-fisted in this prototype, and in the full game it would be a bit more subtle. But, for a prototype and for a basic idea, it works reasonably. So, what I'm going to do here is just activate the boosters by pressing R. This just speeds up the rocket a bit so you can escape the gravitational pull of this planet. Let's wait for our moment and go. No, that was not our moment. See, if they hit you, you go into a bit of a spin. Spin too fast, and you will die. Where are we? Oh no, we've just spun out. We're not actually going to die. Come on. Now, I'm on my 4K monitor at the moment, so the resolution's a bit balked, but if I zoom out, you can see here that it's got the measurements. So you've got your speed at the top there, and the angle, well, not the angle, the angular velocity, the speed at which you're rotating, essentially. Just add a bit of realism. Yeah, this prototype is meant to be very, very realistic. Because this is, well, aside from the really, really fast asteroids, it's pretty realistic. Let's come out of the spin. Yeah, we're in zero gravity, if it wasn't fairly obvious before. And let's try heading up here. Now, we don't want to go too close to the edges, otherwise we will spin out and die. But we also don't want to be going too fast. I should probably stop using these boosters in a second, because they're really only for escaping the planetary orbit. You don't really want to be using them when you're landing, otherwise you'll go too fast and die. Right. Disable the boosters. Let's burn a bit here. Just enable them really quickly. That moon's coming hard on our left. It's actually going to be quite tricky to land this. Yeah, see, we're coming in for a slow burn. Burn is an official orbital term, if you were wondering. Yep, see, the moon is now coming around to meet us in its own orbital trajectory, which is helping massively. We're going to actually hit it quite hard. Oh no! And landed. And that, ladies and gentlemen, is how you do it. And yeah, that's the objective of the game, basically. I'm just going to quickly demonstrate what happens if you die. Let's just go here. Yeah, you get hit by asteroids or whatever. Spin too fast. Space to restart. You hit space, and the game restarts. It's a pretty simple prototype, but it works quite well as an effective demonstration of the mechanics as they would work in this 2D perspective. So, yeah. So what I'll do now is walk you through the code. Now, please forgive the, massive mess that is this script. I haven't had a chance to clean it up yet, and it's just a lot of code going into one kind of area. A lot of mess, not a lot of organization, I do apologize. So we just name a number of game objects and vectors and things here. I will explain all of these as we encounter them throughout the script. First thing we do here is call the rigid body of the rocket itself. And we also set all of these to disabled. So all of those are basically, well, all the different triangular bits. So that one, and that one at the bottom. And the boosters as well. So that, as you can see here, they're not there. But they will activate when you press the respective buttons, which I will get to in a minute. And then I set the rocket speed to 20. And we then move past the commented out code that no longer works. So this bit here activates the boosters. Yeah, it's a bit out of order, this code. The movement is all the way down here. But yeah, this bit activates the boosters. Basically, if you're pressing R and is escape is false, it's just it's a boolean to stop you massively over boosting, essentially. But if you're pressing R and if you press R and is escape is false, then increase the rocket speed tenfold from 20 to 200 and activate that boolean and set the boosters to true, so the two rectangles on either side of the rocket will appear and give the illusion that boosters are coming online, you know. But otherwise, if you're pressing R and is escape is true, which has been set to true here, then this turns off the boost. Oh, that's what it does. I just realized this escape doesn't actually do what I said it did earlier. It's basically a boolean that's activated there so that you can enable and disable the boosters, basically. It activates the boolean here, so if the boosters are already on and you press R again, then it will disable them here and enable them if you press R again here. Yeah, that's what it is. I haven't looked at this particular code since like a week ago, so apologies. And then this is the map here. Basically, if you press M and his map is false, it's the same kind of Boolean idea as up here. It's just a toggle, basically. It changes the orthographic size of the main camera to 100, which basically massively zooms it out, as you saw earlier. In fact, I'll just go a quick demonstration. Yeah, press M, zoom out, toggle to zoom back in. We added that in because while you're in this kind of perspective, you can't really see a lot, and if you're out in deep space, you haven't got a first clue where you are. Because it's obviously space and black, there's no object references. There's nothing for you to reference. There's nothing for you to navigate off of. Now, in the real game, we'll probably have things to navigate off of, but for the prototype, it was a bit of an issue. So I decided to have this zoom out thing, which is something a fair amount of space games adopt, just so you can see where you are, basically. And yeah, and then it activates the boolean again, which activates the toggle. So if you press M again, it zooms it back in to the normal size. And then here it's just the physical rocket thingies, which I've forgotten the name of. Sprites, that's it. They activate when they're basically visual prompts when you boost, so you know you're pressing a key. So you set the trails to active if you're pressing W to thrust upwards or to burn sideways, left or right. That's basically how that works. And yeah, when you're pressing the key down, it's activated. As soon as you let the key up, it goes away. Quick demo. Yep. Holding A, burning left. Holding D, burning right. And obviously, you can't quite see it, but holding, yeah, there you go. Holding W, thrusting forwards. It's a visual prompt, essentially. And then here, yeah, so this is the rotation. It basically adds torque to either side of the rocket, depending on which way you're going. It uses the horizontal axis, so you don't actually have to specify if it's the A or D key. It will just do this automatically. It puts torque to the left if you're holding A, and puts torque to the right if you're holding D. And obviously times the speed float that we set up here. Yep, there. It's all a bit balked now, whack. I do apologise again. And then here, if you press W, it just adds a force forwards or upwards in this case, times the rocket speed, which we set above, which was 20, times time of delta time, because it does it while you press the button, essentially. I didn't do any transform translates or transform.rotates here. I just use Unity's basic physics system because it actually does a lot of the work for you. In a zero gravity system, all you have to do is set gravity, obviously disable gravity entirely, and then literally just add forces and it'll go. Because you disable drag and gravity, it works like zero gravity in real life. The engine basically does a lot of the work for you, which is pretty great. So literally pressing W just adds a force upwards and gives the illusion of thrust, which is pretty damn cool actually. This bit here is a little bit more complicated. I may or may not have nicked this from my year 2 project, Star Beasts. This basically is the false gravity system that attracts the rocket towards the planet and the moon. That one's the planet, that one's the moon. Basically, we're specifying a direction here, so it's the planet's position minus our current transform position, and the moon's transform position minus our position. If this Boolean is true, i.e. if you are within the on-trigger... Where is it? There we go. Yeah, if you're basically within these on-trigger sphere colliders, then basically add a force to the rigid body using the physics system again there, using the float strength of attraction, which we specified up here, times direction 1 if it's the planet, basically heads towards the planet, or direction 2 if it's the moon. Pretty simple stuff, honestly. Although this probably will have to be reworked into actual gravity in the full game, if we make it. And then this is basically just calling the on-trigger sphere colliders. If you're in the trigger collider of something tagged planet, then near orbit's true, and then you'll be attracted to it. Planet 2 is the moon. I just called it Planet 2 because it wasn't the moon at the time. Again, poor organization there. And it's activates is orbit 2, which is that one. And then this is the asteroid one. Asteroids are the ones that are floating around, whizzing around the planet there. This one does something a little different. That actually can be commented out because it doesn't used anymore. But yeah, it adds a force to the rocket, vector3.right times the hit speed. So what that does is when you're hit by the asteroids, it turns the rocket into a spin, as it would do in real life if you were hit by them. And then it also adds torque, so that you're actually spinning right as well. It adds force and torque just to kind of give this uncontrollable spin that you can actually... It's just enough so you can pull out of it if you get hit once, but if you get hit twice, that's it, you spin out and die. And then if you collide with something tagged Doom, this one. Yeah, Doom is the invisible border around the map. If you collide with that, then the camera stops following you around, it disables the camera controller script I've got up here, and I'll go through in a moment. And also activates the press space to restart button. Again, pretty simple stuff. And then this on-trigger exit, basically when you exit the on-trigger colliders, it disables the orbit thing, so you're no longer being attracted to the planet, you can just float around in free gravity. So now we move on to the next, and thankfully more organized script, Speed GUI. I borrowed a lot of elements from this online because I didn't know actually know how to do it, but this is mainly displaying the speed and rotation thing that I showed you in the demonstration in the top left-hand corner, basically. So we're capturing the speed here because Unity, thankfully, has an inbuilt function for capturing speed, or velocity in this case. So all you have to do is call the velocity of the 2D rigid body and call it speed. Same thing with angular velocity. That just means angular velocity is basically just the speed at which you're rotating rather than speed at which you're going forward. And then I've drawn a small GUI box and label here, and basically told them to called it measurements and told them to display the speed and rotation, which we've called up here, and as real-time numbers, basically. And then this bit here, yeah, so this is the rotation death bit that I was talking about earlier. Basically, if your rotation speed or angular velocity is either greater than 1200 or less than minus 1200, because it's depending on which way you're rotating, left or right, then it destroys the player and sets the press space to restart text box. And it's the same thing with this. Basically, if you hit the planet, if you collide with the planet itself, not the on-trigger, the actual proper planet this time, your speed is... If you collide with the planet and your speed is greater than 8, your rotation is greater than 100, or less than minus 100, then you die. Same thing with the moon. Yeah. That's basically the death mechanics there. And then we move on to the camera control script. This one's pretty simple. All we do is just call the player here and start off with a vector 3, which is basically the transform position of the camera minus the player's transform position. And then we call an update that basically changes the transform position to the player's. Basically, it smoothly moves the camera so that it follows the player exactly, which I'll just quickly demonstrate again here. So yeah, as you can see, the camera moves directly with the player. Pretty simple. Oh, we're dead. But yeah, pretty simple script just to do that there. And then the final two, these don't really need to exist as separate scripts, honestly, but, you know. Yeah, so this one basically tells the asteroid to rotate around the planet. Yeah, so it calls the planetary transform position and then gives it a new vector, tells it which axis to rotate around on, times orbit speed, which we've set there, times time dot delta time. And then this is just randomly here, it should be in the other script. Again, organization, apologies. But yeah, if you press space, it just reloads the scenes. That's the press space to restart function. And then we've got a similar thing here. This is the moon, basically telling it again to rotate around the planet in a similar manner to how the asteroid does. Specifies what axis should rotate on, times the orbit speed, which is set there, times time dot delta time. And yeah, that's pretty much it. It's not loads of particularly complicated code, as obviously it's just a prototype, but it was a lot easier to make than I thought it was going to be, because as I said earlier, Unity's physics engine does a lot of the work for you. If you just disable gravity and drag, you have a zero gravity system. You don't even have to code that in. And then all you have to do is just add forces. And the other thing as well is it feels really good. Or at least I think so. Oh, we're dead. Obviously, the difficulty could do with a bit of work here. But as a demonstration of mechanics, I think it works fantastically. Yeah, hitting the planet too hard there, and you die. But yeah, that was just a bit of a walkthrough as to how the game works, and also showing you the code there. Hope you weren't too bored. Yeah, thanks for watching.